Welcome back everyone to this lecture series on data frames. So throughout the course, most of our data exploration is actually done with data frames. And data frames are an extremely powerful tool and really just a natural extension of the Pandas series. And a data frame is a table of columns and rows in Pandas that we can easily restructure and filter. And as a formal definition, a data frame is simply a group of Pandas series objects that share the same index. And that's actually a really important definition and distinction to make. So let's quickly define this a little visually. So here we have an example of just a single series, something we're already used to from the previous lecture, where we have a labeled index and then we have some data columns such as the year. Now here we have an example of multiple series that are actually sharing the same index. You'll notice that each of these individual three series actually has the same index: USA, Canada, Mexico, and so on. And so what we can do is combine these three series that share the same index into a single data frame with the same index, just with the multiple columns. And so that's all a data frame is. It's just several series that happen to share the same index. So this looks a lot like a spreadsheet, which is essentially what it is at a very high level overview, where each individual column is just a Pandas series, and they all just share the same index. So as I mentioned, data frames are really the main Pandas objects we're going to be working with, and they're super useful. And what we're going to do in this series is first just cover the very basics. That is, creating a data frame, and then grabbing a column or multiple columns from a data frame, and then grabbing a row or multiple rows, and then inserting a new column or new row. And then throughout the rest of the Pandas lectures, we'll start learning about different operations you can perform on a data frame. But this series, very basic, we're just going to say, how can we grab information from a data frame? And then how can we insert information to a data frame? As a very quick note, there's going to be multiple parts to this data frames video lecture series, but they're all referring to the same 01-dataframes notebook. Okay, let's get started showing you how to create a data frame from Python objects. I'm going to head over to a Jupyter Notebook. Okay, here I am at the Jupyter Notebook. I've already imported NumPy as NP and Pandas as PD. And what we're going to do in this video lecture series is show you how to create a data frame from Python objects, for example, a NumPy array, or how to actually read in a CSV file for a data frame. Keep in mind, we're going to have an entire lecture going over various data inputs and outputs later on in the course. For right now, we're just going to show you how to read in a simple CSV file, which is a comma separated value file. But first, let's show you how to create a Pandas data frame given something like a NumPy multidimensional array. So this is really common, especially if you want to kind of play around with some data just to explore the different operations you can do with Pandas. What I'm going to say is np.random.seed 101. And recall that setting a random seed is just a way to ensure that your random numbers are the same as my random numbers, and that this number, 101, is essentially just an arbitrary choice. So in the same cell, then go ahead and follow along and say my data is equal to np.random.rand, and we're going to say rand int. Recall that's a way of creating random integers. And what we do is we say the low and the high for the range, and then the actual size or shape we want. So what I will do here is say low is 0, and then high is 101. Recall the high is exclusive, meaning it can go up to but not including 101. And the actual size or shape is going to be 4 by 3, 4 rows by 3 columns. So if you run this and you set the same seed as I do, and both of these are in the same cell, then you should see, upon hitting my data, the exact same numbers I'm showing here, 95, 11, and so on. So here we have a two-dimensional array. And you can already see there, kind of looks like a spreadsheet. We have the rows and the columns themselves. So what we want to do is actually create a data frame. And what we need for a data frame is an index. We'll say my index. Let's go ahead and pretend these are states. So we'll say California, just the abbreviations, New York, let's say Arizona, and then let's say Texas. So that's going to be my index. I need it to be 4 items since I have 4 rows. Recall index goes with the rows. And then let's create my columns as well. It's also going to be a list. And let's pretend these are monthly values of some sort for each state. Maybe they're monthly tax revenue values or something like that. So say January, February, and then March. Okay. So now let's create the data frame, and we're going to build this up step by step, similar to what we did when we learned about Pandas series. I'm going to say df is equal to pd dot, and then here I'm going to call data frame, which is the way you construct the data frame. Quick note is that both the D and the F are capitalized, so sometimes that kind of confuses beginners. And then you'll notice that we really have three main parameters for the data frame. Previously, when we were creating a Pandas series object, we just had to provide data and index. But recall that now we're going to have multiple series inside this data frame, essentially multiple columns. So that's why we have this essential third parameter, which is columns. But right now, let's see what happens if we only provide the data. So I have this two-dimensional NumPy array. I'm going to say df is equal to pd data frame and pass in that data. And then once I do that, I can call df, run that, and what's really nice, if you're working with Jupyter, it gives you this kind of slick output of the spreadsheet. So it'll automatically highlight rows for you. And depending on what version of Jupyter you're using, this display may look slightly different. Or if you're using just another IDE, you'll get it printed out as a table. But here we can see we have the data frame, and if you only provide the data, Pandas automatically will label the index, 0, 1, 2, 3, and it will automatically label the columns 0, 1, 2, and so on. So now let's come back up here to my data, and let's also provide the index. We'll say index is equal to my index, and I'll also say data is equal to my data. As I mentioned before, technically I don't need to provide these arguments. This is really just showing you what each argument is taking in. So we rerun this cell, and now I see the index here has been created. And you'll notice there's nothing above this index, basically showing you in bold that this is the index, not another column. And we'll talk about more details of how this is actually displayed in Jupyter later on when we talk about things like multi-index. But for right now, you can differentiate an index by the fact that it's bold here and doesn't actually have a column name. You'll notice Pandas still automatically labels these columns 0, 1, 2, and so on. And finally, we can provide the third parameter, columns, and we'll say it's that list my columns that we created. We run these again, and now I can see what my typical data frame is going to look like, where I have these labeled columns, and then I have also this labeled index. And what's nice is if I just want general information about a data frame, I can say df.info, open and close parentheses, and you'll notice it immediately reports back a lot of useful information, including the index. So you can see it has 4 entries, 4 rows, California, Texas, has a total of 3 columns. It also reports back how many non-null values we have. We actually talk a lot more about null and missing values later on. And it also tells you the data type. Here we have 32-bit integer and how much memory you're using. So that's really nice if you're dealing with really large data frames. It's nice to report that back and see if you're pushing against the limits of your RAM, because this data frame internally is just stored inside the RAM of your computer, which is why operations on a data frame are typically super fast. Okay, so that's one method of getting a Pandas data frame, which is just manually creating it yourself with some NumPy data, your provided index, and your provided columns. Realistically, however, we're going to be reading in data from something like an Excel file or a CSV file, or maybe even a SQL database. So now let me show you how to read in a Pandas data frame from an existing data file, such as a CSV file. And something I want to note here is that typically when I'm teaching students who are new to Pandas and new to things like file paths in Python, there's a lot of confusion over what they need to provide in order to understand the file path for Pandas. So I really want to point out here that in the DataFrames notebook, let me bring it in over here, the DataFrames notebook that we're following along for this lecture has a really good discussion that I wrote up for you on understanding file paths and how to print your current working directory and how to list the files in your current directory. I'm going to go through that now, but in case you start getting errors, really take the time to read this and understand this. But let me go ahead and essentially explain to you how to read in a CSV file from Pandas. So the first thing we need to do is understand what is the actual file that I want to read in. And what I'm going to do is if I hit File Open here in Jupyter Notebook, you'll notice that underneath my Pandas folder, if I start scrolling down beyond the notebooks, you'll see that I have some CSV files, some Excel files, some more CSV files, and if you keep scrolling down, eventually you'll see towards the very bottom this tips.csv file. So a CSV file, if we actually just click on this to open it, you'll notice it's essentially data where each data point is separated by a comma. And so that's where the .csv comes from. It's a comma separated variable file. So every single variable is separated by a comma. And later on, we'll show you how to work with things that are separated by semicolons or tabs and so on. But right now, this is probably the most common file type we'll be working with throughout the course. So let's show you how to read this file in as a Pandas data frame. So there's two things that are key here. One is to understand where your Python code is currently located. And the second is to understand where your file you're looking for is currently located. So let me close this tips.csv tab. And let's first answer that question of where is my Python code located? And if you're running this in Jupyter Notebook, you can easily find this out by typing pwd, which is print working directory, and run that in a cell, and it's going to automatically report back the file path. And there's two things to note here. One is the full file path, which means it's basically reporting where this Jupyter Notebook is on my computer. You obviously won't have the exact same path because you won't have the same username I do. And the second thing that's really important to note here is the actual formatting. If you're on Mac OS or Linux versus a Windows operating system, these backslashes may be forward slashes depending on what operating system you're in. So in general, you should use this to understand both the formatting of file paths, such as using double backslashes, and the full file path location of where your Python code is currently located. So right here, this is where my Jupyter Notebook is located. Now, if I wanted to know what files were in my current directory inside of Jupyter, I could type ls, so this is not a 1, it's an L, for listing the files in my current directory. So in a Jupyter Notebook, if you go ahead and type in ls, what it's going to do is it's actually going to report back all the files in your current directory. So here I can see series, data frames, and so on. I can see the CSV files, and then here's that tips.csv file, which we're going to try to open, as well as the untitled notebook that I'm working in right now. So what I need to do is provide the file path to this tips.csv file to Pandas. And the way I do that is basically there's two options. One is to say df is equal to pd read, and you'll notice if I just say pd.read underscore, recall pd is how we're actually importing Pandas. So I'm calling this off of Pandas directly. So Pandas as pd, and then I'm telling Pandas, hey, I need you to read a file for me. So pd.read underscore, hit tab here, and you'll notice there's a lot of different file paths that it can read in. It can read in HTML files, SAS files, SQL, and so on. Right now, we're just going to work with CSV. We'll cover a lot of these later on in the course, but for right now, we're just going to say read CSV, and what it needs to know is the very first argument, the file path. Where is this file saved on your computer? And technically, the file path is relative to where you're working with in Jupyter and your Python code. So because tips.csv is in the exact same location as my untitled notebook, I can technically say tips.csv, run that, and if I call df, now I see this entire data frame loaded up. Now, as I previously mentioned, beginners often accidentally make a mistake here and they'll get an error saying file not found. And let me show you what that error actually looks like. I'm going to delete data frame here so we get an empty cell. And let me actually initiate this error by spelling tips.csv file incorrectly. So here I can see that I have two P's. It's incorrect, meaning, of course, Pandas is not going to be able to find the file because it's spelled wrong. So if I run this, you will get this issue or error, file not found error, and saying file tips.csv does not exist. This is probably the most common error I see people who are beginners to Pandas get when trying to read in a file with Pandas. And so what I want to explain here are the debugging steps in order to fix this error. The very first one is just make sure you actually spelled the file correctly. And the main way to do that is to either come here where you have a list of the file names and double check it against that, or you come to Pandas or wherever your CSV file happens to be saved, take a look at it and see that tips.csv is spelled correctly. Okay, so let's imagine that I know I spelled this correctly, but I'm still getting this file not found error. So in that case, the issue is that this .csv file is located in a different directory than your Python code or Jupyter Notebook. If that is the case, we need to provide the full file path for this .csv file. So what you need to do is figure out the full file path, essentially, for this CSV file and where it's saved on your computer. And you also have to make sure, if we scroll back up here, that it's formatted in the same way that PWD recorded. So for Windows users, that's double backslashes. For Mac OS and Linux users, that's typically a forward slash, a single forward slash. So what we're going to do is we're going to provide the full file path. So if I copy and paste this right here, so let me copy and paste that, and then come back here and paste this in, and then let me add in 2 backslashes. I'm going to zoom out one level so we can see kind of the whole deal of what's happening here. What I've done is I'm telling it now to read a CSV file, and I'm passing in the full file path of where it's located on my computer. Keep in mind, your file path would be different than the one I'm showing here, because obviously this is my specific username. But if you're trying to read a CSV file that's located somewhere else on your computer, essentially maybe it's located under your downloads folder, then what you would do is you would pass in users, your username, downloads, and then the name of the CSV file. Essentially trying to figure out what is the full file path that Pandas has to go to read in the CSV file. And now that allows you to read a CSV file anywhere on your computer, as long as you provide the correct full file path. So if I run this, you'll notice now I don't get that error. And this is actually the same thing as running just tips.csv. The reason I was able to run just tips.csv is because my notebook is in the same location as this .csv file. If that is not the case, then you do need to provide the full file path. And you also need to make sure it's formatted correctly. Typically that means 2 backslashes for Windows users or a single forward slash for Mac OS or Linux users. And you can always check that by using PWD inside of Jupyter Notebook. The thing to note here is that these commands, PWD and ls, those are specific to Jupyter Notebook, not to just Python code in general. So keep that in mind. All right, so now that I am able to provide the full file path, I can run that cdf, and now I have the entire data frame with different column names and then the different rows. All right, so make sure that if you're still getting some sort of error, that you read the instructions shown in the DataFrames notebook. But again, make sure you check that you're providing the correct file path and that you're spelling the file name correctly if you're running your Python code from somewhere that is not in the same location as tips.csv. If you're still having trouble with this, one quick fix is to simply move the file you're trying to read to the same location as your notebook or Python code. However, I would recommend in general that you become very comfortable with providing full file paths to whatever file you're trying to read, because that will allow you to read data from anywhere on your computer. Okay, so make sure you read the notebook if you're still encountering that file not found error. And as always, if you run our notebook from the same original location and just run the code, it should always work for reading in a file, because we've specifically designed our notebooks to have the file paths be correct from their original location. That's why this DataFrames notebook is in the same location as this tips.csv file. Okay, so we've shown you how to not only create a data frame from scratch using a NumPy array and then your own Python lists, but also for right now, how to read in a basic CSV file. We're going to cover data input and output further on in the Pandas lecture series, but for right now, we've just learned how to read in a simple CSV file. We'll learn a lot more about reading in from SQL or Excel later on in the course. But now that we have this data frame file ready to go, let's continue on in the next lecture. We're going to talk about grabbing information from this data set. I'll see you there.